Perfect. Okay, so um, now you are going to work in the design review in the activities. We're going to work. I was thinking about the article, but I have changed it, and now it's going to be. We're going to work on the 3D kinematics. The 3D kinematics, and then in the article, if we have time next class, we can work a little bit on it, but not much. The important thing would be the kinematic. So the true kinematics, there are some equations. I will update these questions, so don't take it at this moment. I will change them a little bit, and I will add a few more questions. So, but just for you to keep in mind. Okay, we are going to see this in the design review. There is one which is close this design review. Okay, we have this DisMe 23 design for printing. So what we have there is the class that we're going to have now. And if you want to print it, you can print it, and you can follow it in your mobile, your tablet. So it's what are we going to see now. In TEOM, if you remember the final part of TEOM, 3D kinematics, was seeing this. This is perhaps, sometimes there are not much time to see this 3D kinematics. At this moment, for this class, I think would be better if you sit here, because there will be a lot of following like a class. So it's better if you sit in this for this class. Okay, because in this class we are going to do a lot of this. So what do we have in this? We have this for printing, and you have the solution for two examples, the 9.2 and the 9.7, which is very similar. Both are very similar. And then we are going to work on these kind of things later. But we are going to, I want you to focus this now for you to know that in one point, when we're working in motion, we're going to work using velocities of rotational parts. So that's why we are going to do it, okay? And then you will have, this is the solution. This is the complete solution. I will be making some notes for you to explain, because since I know that probably you are not that fresh about this topic, you have all the entire solution. So it's just refreshing. And if you didn't have time when you saw TEOM to work on this, then working now. In particular, these two. And then I will provide you the same subject with a different angle. And then your task will be doing at home the exercise with a different angle, and I will ask about this exercise. Okay? And then these are the previous exercise because we're doing early in the fourth class, because for you to have time. Okay, but then you will have time now to do what we are doing now, to do it this class, and then the next class, make questions, refresh, we'll finish. We will have the evaluation verification about the questions, and then the next class, the verification about kinematics. So for you to have time. Yes? Perfect. So, and then this is the solution, and just to refresh. Okay, so the code, have I mentioned about the code already to you? Because sometimes I do, sometimes I don't. No, you haven't mentioned. Yes, this is a code for emails, which I use. And why I use this? Because it's easier to identify the emails. So for example, if you if something happened and you need to find, say, DisMe 22, so this is all the emails that you have DisMe 22. So what I do, I put DisMe 22 in the initial of the email. So you will know that I am sending that email. If you send me an email, I advise you to do the same, because then you can also identify your emails. So if you do it, you will identify easily all the emails that you have used in this subject. Okay, that's what. So that's the reason of the code. And what anyone, no? If you have 21, plus you have the emails of 21, and the same any subject. So once I was this person who sent me this an email, and then I said, no, I haven't received that email. And then he had used the code, and he put DisMe 22, and he got the email. This is the email, and he had made a mistake in the email, something like that, and that's why I hadn't received it. And he found it in a second. So the advice is to do it. Okay, this is something I would do other ways. If there is this a phrase in which, when you read this phrase, usually there is one word which you don't identify, and when you know that lubricant is the corpusculo, then the sentence makes sense. So it's the same in anything. Sometimes for just one tiny thing, you miss a concept. So it's asking or searching for the answer and not continuing until you know exactly what is that. This is not an easy task. DisMe 3D kinematics, it's fairly complicated. That's why we are going to do this, some examples relatively simple, because that's the idea. The idea is to work in something which is manageable. And also in the topics, if you go to the Miriam, which is one of the books, there are some simplifications, which usually there are simplifications, okay? Okay, let's refresh what we have here. Here we have this electric motor, and then it had two rotations. One, when you got this, then this case is 60 RPM. Okay, and we got 60 RPM. And the other rotation, which is the W sub 0, which is 120 RPM. So we have this, and this is rotating. This is an electric motor, and it's fixed. This is 30 degrees fixed. All this is in this subject. Okay, it was left in Spanish for, in this case, is a reference. Okay, so that's the situation. So we have the electric motor. What happens if there is no rotation in N? Then in the motor, you got rotation, and it goes in this angle. But this is changing. But when you have two, is when it gets complicated, because you have the addition of two different movements. So we are going to work, and we are going to do analyze this later in motion. Okay, so one of the first things that you should do your own drawings about how you understand this. This is how I did. And I set the axles as I wanted. In this case, I decided to make the main ones with in the capital letters, the mayúscula. You got this angle rotated 30 degrees. So the X is in the same, and we rotate only around the X. That's why you have 30 degrees for the Y, the lower capital, lower letters, and Z, lower letters. And I have this, it would be the axles I. No, this is I, I, J, J, and Z, Z, K, K. So it would be is the standard ones for 3D. If we have a system like this, we have this movement. The end rotates in a circle. So since the end rotates, so in this case we call it omega, call is a circle. It goes like this, depending on the direction. Yep, you see it? You see the motor, it will rotate in this way. And then the other one will be rotating and a different cone will be like this. So the other one will be a cone depending on the direction. And this are two circles. So these two circles create these two cones. And these are called cone from the space and cone for the body. This is the technical name. What makes which is a space with this body? It depends on which one has only one rotation. You have one that has only one rotation, and the other that has two rotations. So when you analyze which of those has only one rotation. Usually, one of them will have only one, and the other will have that plus the other one. That makes the difference between these two cones. Okay, so
the space has only one rotation.
yes, and let me show you also something which I didn't do. Yes, you will ask one of them. We have only one rotation, and the other we have two rotations.
And the space is one, and the body is two.
Yes, this is how it is called. Let me show you as well something which I didn't. We have the 3D kinematics in the rigid body. And the 3D kinematics is also the same as it is in TEOM. So we have the body. If you still have the TEOM subject, you will also find it. Okay, so here this is one. This says the fixed. You didn't
We didn't reach that far.
in TEOM.
Yeah.
Okay, but you did the previous one.
Yeah, we did cinematics.
Okay, perfect.
Mechanics, but we didn't do.
Perfect. It means that you have the basis for this. Yeah. So even though perhaps you might need to refresh, but the basis you already have. Okay. Perhaps now will sound like Chinese at this moment, but if you do it, you should be able to switch. That's why you will able to ask me next class. Okay, so this is one that only rotates. It's called precession. And there is another that has translation and rotation. It is succession. This is the technical name. Precession is succession. The one that has only one is precession. And this is also the technical name. So it means that this omega precession y capital lower letter omega, omega sub 0. Okay, no worries. You have the basis. That's the important thing. Yeah, I know that. I know that sometimes you don't, but that's okay. That's why we are doing this review, because if you haven't, you do it now. Okay, and we will focus on two particular problems to focus in applying it in these two situations, and we will also work on this in the motion. That's why it's important for you to understand it. Okay, so precession succession, and this is only rotation. Only one rotation, and you have two rotations. Okay, perfect. And then one other important things here as well is in the W. Here, this, let me change the number. Now, okay. So let's change to this other one. The same. No, it's this one. I am selecting a different one. Now, okay. So, and this is another which is important. The W, and that is the omega. This omega is the addition of these two movements, the two rotational. If you imagine this cone, now imagine these moves. What happened with this? And the diameter changes. So imagine that these cones are changing in the diameter. What will happen with this value? This is going to change. This is going to be, if it is smaller and this is bigger, this will be closer to which one? To the smaller one. So anyone who is smaller will be closer. Depend. Yeah, it's slower. Is if it is slower velocity is also a slower circle. No, the circle depends on the radius. So it's a combination of and depending on the radius, do we have more or less speed? Okay, so it will be moving one side or another side. And this is vectorial. This is, you have two vectors. It's going to be closer to one or closer to the other, depending on the speed that you have. Okay. Yeah, it will be changing. But this is a vectorial addition. So another thing is you have the angular velocity. The angular velocity is the addition of the two rotational speeds. The tricky point here is which axle you have. This is the why the lower letters o the capital letters makes the difference. La mayúscula y la minúscula hace la diferencia. That's why what you need to do is you need to convert this to this axles or this to these axles. And you convert one of them to the other. Since we are working on the motor, let's put everything in axle of the motor because we're working in the motor. The question is the velocity of A. The velocity, the angular velocity acceleration cones velocity and acceleration of point A. So, and the velocity is one value which we can get from motion. So we're going to work on the velocity. Since we are asked about the body of the velocity of the motor, of the section of the motor, section A, we're going to convert this into this. And that's why I have this diagram. So this omega is the same that we have here. I am only verifying. This is something which I like to do because it's easier for me to identify, because in 3D it's very easy to get confused. Extremely easy. That's why I prefer to do something like this, and then I draw the axles here. Which one is Y, which is capital, which is lower, capital letter, which is lower letter, and then defining this and this and this, and this is very useful for me because otherwise it's very easy to get confused. And then when we do this, we have this is the same. And this is, as mentioned, when you have the cosine or the sinus of 30 degrees, you can easily convert a half a square 3 divided by 2, and you get the value. This is the conversion. So I have this goes this addition, and I convert this into the same axle. And once I have this, I can continue working. And then I add a sub-zero plus omega, put everything in the same axle, and I get to this value. The angular acceleration, this is constant. This is constant. This value is 0. We can go where is this one? Okay, here. It's happening now. That's the problem with this. Sometimes in the tablet, it's not. It doesn't go that fine. Sometimes in the computer, it's perfect. In the tablet, sometimes. Oh, what happened? I was kicked out. Perhaps that's why it's not. It's not. Yeah, that was the reason. For some reason, I was kicked out. Who knows? Okay, so this is the explanation. This is of the cone. And this is the velocity. This is what I said. Addition of these two. Okay. Okay. So we have the normal and tangential accelerations, the velocity, equation of the velocity, and okay, and this one. So since we have this configuration of these two rotating around the same point, we have you have these two cones, you have this and this equation. And then we have done this already, and now we are going to do this one. The difference is, or that we need to define one single axle. The lower letters, the minusculas, the capital letters, the mayúsculas, but only one. Since we have selected to do it in the axle of the motor, como seleccionamos el eje del motor, pues lower letters all the time. And then we have this value. This equation is, and then you have here in the typical way in which you cover the axle and you do this minus this, minus this minus this, plus this minus this. Remember that? Okay. So you have here also the equations for you to refresh. Okay. So in this case, since you have these two zeros, we have only one, and the rest no. 0 and 0. When you multiply, it's 0. So you have acceleration anomaly in this axle. And then for the velocity, Yeah, it seems like if when you go to, I will check, I will verify with the guys of it if technology. Okay, so if you want to take the velocity and linear velocity of point A, which is what we are asked, you multiply this, the total velocity by the vector r. Do you remember which was the vector r? One is velocity. Vector r is position, vector position. So you have two. You have one which is rotational, radians per second, and the other one which is distance, which is meters. You multiply radians per second plus meters, you get meters per second, which is this. These are the equations that apply to this particular system that has rotation around the same axle. That's the particularity of this. That's why you have this cone. You have this cone because it rotates around one same point. From this point, you get these rotations, and also from this point, you got this rotation. You have the rotation of two, and since this is a vector, you apply the right-hand rule, and this is the vector, and this is the vector. This is a vector going around that axle. That's why you have those equations. The reason to have those equations is because this system complies with that type of combination. Usas esas ecuaciones porque este sistema cumple con esta combinación. Okay? Yeah, the important parts I will be saying in Spanish. Yeah? The parts that are like important to refresh, okay? To remark. Okay, so that's why we have these equations. Es la razón de usar estas ecuaciones. Okay? So, and the important thing is not to get confused in the vector. This is the total one. And the, so you have here velocity in A, applying the equation, you have this, and then you have the values. The vector, the position, the vector de posición, usually you call it the OA or A with respect to O. This is two ways you say the same. And this is the value. In lower letters, minúsculas. El eje de las minúsculas. The axle of the motor. This is the eje, ese es el eje del motor. It's important. Therefore, if it is the axle of the motor, this must be the axle of the motor. Este y este deben ser de los ejes del motor. Si no, no estará bien. You can do the same in the axles of the capital letters, but you will have to get two in the same axle. So whatever you choose, you put the values in the same. Okay, so we continue. And then we have here the solution. And this is the value of this vector. No worries. You have to go at home. You have to go through this. Okay. Refresh. You have to go through this, but this moment is for you to refresh, and then when we finish, we will, if we have time, we'll get back to focus in some subjects. Okay. Because for you to have time to refresh, I am recording the class. If everything goes fine, you should be able to see the class if you need it. In principle, huh? I am recording it. It might work, it might not work, but usually it works. Okay? Yeah, but it has happened sometimes that There are no recording for some problem, but usually it works. Okay, it works. I will put the link in the usernet and let you know. Okay, so this will be the simple one, and this is another a calculation in which I am defining the linear velocity with regard to the point O, the origin, in the point A, for this and this. Which vector is this one and which vector is this one? The omega, the capital omega was the main, the one who has only one rotation. And the sub-zero was the other one that has two rotations. So what we have this would be the velocity for this one, and this will be the velocity for the other one. And if you had additions, you have the same value. So what's the meaning of this? You had minus and you had plus. It means that one will be in one direction and the other will be in the opposite direction. And if we go to here to analyze this, it makes sense because this is rotating in this way. So the linear will be towards the minus. The other one is the other way. So it's positive. One is negative, the other one is positive. But the combination of these two is the total one. One will be rotating this way, and the other will be rotating this way. So this is what you have. You have the combination of two different movements in one point. That's why I put this example. Okay. Let's go to the general movement. This is more complicated, but we are not going to go into explaining how this equation works because there is no time for that. Impossible. But what we can do is to apply the equations. We can do that. So, yeah. Yes. We have this is the 3D, which is in the usernet. So, general movement. General movement, we go into the called arrastre y relativo, and this was a combination of two movements. You might have to go back into the 2D to refresh a little bit about the arrastre y relativo, because you are applying the same again. So you combine these two movements. You had one which is rotating, and the difference will be that in this case, it's not rotating around the same axle, because this rotates, for example, around this axle. So perhaps these two, this and this, yes, but this not. So in that case, yes, but only two of them. But the P is not rotating around the same point. So these two are the same as before. This not. And that makes that it would be a different solution. And then you need to consider the velocity for the arrastre and velocity for the relative.
The relative is the one that doesn't.
Yeah. If you see, it's P. And you see, it's vector B, A. B, A. So it's one that is not rotating with regard to this one. Okay. And in the other one is rotation, velocity, rotational velocity. Is OB, vector OB, and vector BA. And if we go, OB, OB, and B, OA. So it's rotational with respect to O. So depending on which is the point of rotation, you apply the equations. Okay, so we are going to apply this, a similar condition. So we go to the solution. And the first thing is for you to draw your own drawing. Tú tienes que dibujar tu propio dibujo. If you don't draw it, it's impossible to understand it. Impossible. The only way that I can see that I have found myself able to understand this is doing it myself and changing the axle. If you go to the Marian, it's a different axle than the one I am using. Yes, but you can change the axle, and then you can use different, and then it forces you to verify. You have the values already. And using a different axle, o sea, rotating the axles, rotando los ejes, then you use a different direction, and then it's slightly different, but the solution is the same. So it helps you to think, okay, that was the solution now. So one thing which I recommend is to change the axles, that you change the axles and then do it in a different way. Okay, so in this case, it's different because we had this point here, and they have one distance here, another distance here, and they have this other thing, and this is rotating around this point. So it's different. So it's a different condition. You have the rotation, but it's not around the same point. So in this case, the question is velocity in v plus velocity given to the rotational velocity at the point A and relative velocity. This is the same equation as the one we see before. Data, the two rotationals, precession, succession, angle, which is constant. And we are asked to find velocity, acceleration, and acceleration from the disk. But in this case, we are going to focus on the velocity and the acceleration of the point A, which is the important data and the data we got from the motion, and the one which is easier to understand. The other one is more complicated. Okay, so what we have here is we always go relative to what? Relative to what? Siempre vamos relativo a qué punto? Always. So we are now talking about this, the main. We have these two. So we have the one from precession, the one who rotates alone, and we are defining within 0 and b. So this is between the points 0 and b. So you put the vectors from 0 to b, and you, in this case, you must define in which axle you are working. Since it's easier to work on this in the capital letters, we already have the information from this. If we go back to the solution, you will see that we already have this. So I decided to do this and this. So if it is capital, you maintain capital. This is important. But since in the axles that I define it, because the main were given by the drawing, but I change it. Okay. No, in this case it's the same. The one I change is the previous one. Yeah, in the previous one I changed it because it was set and I changed it to Y. So you can either use the same or you can either change them. It's up to you. I recommend to change it. So you have this, and depending on the axles, then we define the points. In this case, we had the O, we had the B, we had the A. So from between O and B. So we're analyzing the first one, O to B. So in this case, we have two. We have this and this. We are analyzing this first effect. In the point in which we have the initial point from the other rotation. This one is rotating around this axle. So we have, okay, we have OB. This is the same. There is no change in sign, no cambia el signo. The same axle is I mayúscula, I minúscula. We have the result, and then we have the final value here. Okay. Then we need to combine. We have 3 omega. Omega is 3. This is omega 3. Now we are going to do the solution, the same solution, but now we are going to be using the other vector, which is the P for the motor, and the distance. And then we're converting this 3 in these 2. That's why I have these other 2. No, this is, sorry. This is lower letters. So we are converting this K into lower letters using this. And then in the other case, we verify we have this value and this value in lower letters to use these 2 vectors in lower letters. And then we have here the distance between A and B. From A to E. This will be the vector. So we said one first from here to here, and the other one from here to here. And in this case, we use the omega, capital letter, and the other one, we use the P. So it's vectorial, you are adding the rotations. You are adding the effects. VA, B, velocity in B, plus. This velocity in B is the one we calculated, and then we are adding the 3. One of the important things that you need to go at home to compare these 3 equations and to see from relative to which vector and relative to which distance. Es importante que en casa verifiquéis esta ecuación que está aquí y verificar cada uno de estos vectores relacionado a qué velocidad están y relacionado a qué vector de posición, de dónde a dónde. This is very important. Doing this verification. Y tenerlo claro. Ah, mira, esta va de aquí a aquí con este movimiento. Esta va de aquí a aquí con este movimiento. Este va de aquí con este movimiento. Okay. In the case of the acceleration, which is slightly more complex, so it's similar. In the acceleration, we add Coriolis in this case. In acceleration. So in Coriolis, we have, so in Coriolis, we have, in acceleration, we have the same again, arrastre, relativo, Coriolis. And then here, the difference here is that one of these is 0 because there is no acceleration. So only the normal ones are the ones who will be calculated. This and this, the t, the tangential ones, this is t of tangent. These two are 0 because this constant speed. You see this constant speed is 0. So that's why you reduce this.
We are always going to work with constant speed.
Yes, because we're going to make the exercise less complex.
Okay.
That this is already complex.
Yeah.
So we don't make it more. But if we were in constant, you will have to add these accelerations. Okay. So you will have this, and this is pretty much the same. Adding Coriolis, because we have two rotations at the same time. And the same, the arrastre is relative. So, and then that's why Giro Constante, you have only one. And this will be the equivalent. There were two equations, typical equations, and one of them was for the tangent, which was the equation for the acceleration, the tangential acceleration. That's alpha. R. And the normal, omega cuadrada, R. So, because typically this is 0, you don't worry about the tangential one. You worry only about the normal. And the normal is the square of the radial velocity times the radius. And this is the same. That's why you have only the normal. And you do the same again. Which axle are you using? In this case, we are using the lower letters because it was simpler given the values we have to make it simple. Okay, we can do this and then later we can convert if we need. No problem. So we do this. This is the solution. Those are the values. And we have this acceleration.
Why is the same the capital and the capital?
Because it was defined here. Because it's parallel. So if you use the right hand rule, it will be the same. That's why. It was defined in the same orientation. The key point is orientation. La palabra importante es orientación. ¿Cuál es la orientación que tiene cada eje? Eso es lo que te va a definir.
It's the same for the small, the capital and the...
Yeah, because if you put your right hand, it will be the same, this and this. It's positive. Okay? Well, so that's why you have the normal acceleration, and you get one value. And if you see here, the difference, this is also a normal acceleration with the same vector. What's the difference here? What's the only difference? El vector distancia, el vector posición, the distance from where to where it's going. That's the only difference. So what you have there, you have two normal accelerations applying given to the movement of this, but with different distance. You are examining two locations. The effect of this rotation in two different locations. That's why you have the same. And then, yeah, by the final part, when you got Coriolis, and always, whether you can use it in capital or lower letters, and later you convert, but all of them must be the same. If it is capital letters, so it must be the one for capital letters. If it is lower letters that's here, you can do that as well. And the result will be in lower letters. The axle will be the same. That's the important thing here, to make everything the same. And here, why? Because it's easier, because we have only one, the 8. So that's why, okay, let's make it easier. And later, we see we need to convert. Here, then we analyze the axle to see if we need any conversion. Set is different. So in this case, we need to have a conversion. And when we do the conversion here, here. So we do this conversion here. From this, you go to this. And then I always like to do this, because for me it's easier. Because otherwise, it's very easy for me to get confused. So I see carefully which is the axle, and then for me to identify which would be this one. So we're converting this into capital letters. We first made it with the lower letters to make it easier to calculate, and later we convert. No, we don't want to do that. Okay, then you convert first, and you get this value from the initial calculation. It's up to you. But as long as you do in the same. Tú podías, yo podría haber hecho aquí mayúsculas y entonces convertir este 8 a mayúsculas y meterlo aquí. Y sería todo mayúsculas. Y después, pero me hubiese dado esto directo. O viceversa. Lo que importante es que siempre sean de lo mismo. La recomendación es que tú lo hagas diferente a los ejes que yo estoy usando. Hazlo tú con minúsculas. Donde yo hice mayúsculas, tú hazlo minúsculas.
El vector P por
Sí.
P.
Por el vector producto cruz de vector P otra vez por R. Esto es velocidad lineal. El vector P es el que gira en el motor. El vector de velocidad del motor. 120. ¿Vale? Okay. So, try to do a different one. Intenta hacerlo con los de manera opuesta a la que yo lo hice. Inténtalo. Y si puedes, cambia los ejes. Realmente vas a aprender bastante si lo haces así. Bueno, yo he aprendido un montón así. Por eso te lo digo. Okay. So, in the final one, then, we just add everything. We define this, the question again. This is the value in the lower letters, in the capital letters. So we have everything in capital letters. It was the question, the initial equation, and we define all the values that we have. Verifying that this is capital letters all the time. And this will be the final acceleration. This is the value that we will analyze in motion. Este es el valor que analizaremos en motion. Velocidades, aceleraciones. Okay, now, it was how it is solved. Okay, so you have this in the usernet. Now, in the time we have, now let's go back and let's see now more or less some things you might think is important. Which do you think would be important now from everything you see from the beginning?
The axis is very important.
The axis, okay. Okay, what's the question? ¿Qué pregunta es? ¿Cuál sería la pregunta? Let's go back to the first one. Vemos el programa inicial. Ejes. ¿Qué pregunta? Y lo trabajamos ahora. ¿Otra vez? ¿Cuáles gira? Vale. ¿Cuáles rotan? Okay. We have the typical one, the typical axle would be, this is the typical X, Y, and Z. Yep, the standard one. This will comply with the right hand rule. If you use this, you can be sure that it's going to work fine. If for any reason you want to change them, you maintain always the same. Entonces, si lo quieres cambiar, es mantenerlo siempre. For example, you can do like this. It will be 1. Or again. And again, let's make it here. The tricky point here is, where is the positive? Aquí la pregunta es, ¿dónde es el positivo? ¿Hacia dónde es positivo? Let's say 1, 2, 3. Where is the positive of Y? ¿Dónde es el positivo de Y? En el 3. In the number 3. Yeah. Hacia la izquierda. Would be positive. So that's the important thing. If you see the example, they change the X. The X is negative. Because they did this. They changed it, and they changed the Z here. So it means that they continue the rotation. And the 4 would be something like this. So they did, I think, the number 4. The Z is here, the Y is here, and the X is on the lower part. Let's change. Let's see. Yes, this is what they did in the exercise. I decided to change that and to make it Y and Y. I'm the one who decided. You can try to do it as the Marian says, for example. And you will see that it's the same value, but the positive and the negative is different. The one if you do it like this, the one in this result is positive. In my result is negative. And the X majuscula and the capital letters, where is the X in capital letters? And where is the Y? In the capital letters. No se ve, but we can write it now. Where is the X mayúsculas, the capital letters? Towards us. This is the capital letters. And this is the Y capital letter. It means that if you solve using this configuration of axles, if you use the capital letters, the vector goes this way, it's positive. But if you in the lower letters, lower capital is the minúsculas, positive goes the other way. Because you have chosen them.
I can use the lower letters.
Yes, this is what I did. If you see mine,
yeah, yours is positive.
if you see mine, In my case, I decided to make it positive both. But if positive are both, then both are the same. Yeah, so that's the important thing. Otherwise, the directions will not fit. Yes, this is important to because the right hand, because we are going to be using the right hand rule, and then to make the right hand rule to work, it will be the same. The relative of x, y, and z. Okay. Yep. Try to do it following this, following the drawing. It's interesting. Okay. Other question. What else from this first exercise?
You need to examine.
Yes, I'm going to give you. We're going to give you a different angle. Instead of 30 degrees, say 20, and then you must solve it with 20 degrees or 60 to make it easier. Okay, you solve it with 60. I will give you the same value with 60. I will give you some results for you to have the guideline, and then you solve it. Yes. No, because we are going to use it in motion. That's why. You're so sure because perhaps perhaps this is something new. What are going to evaluate? Yes.
Any value of this class, I think it's something new.
Okay.
Everybody makes their own.
So
Make them.
yes, everybody has their own, for sure.
Yes.
Okay, you have the basis. What I want you to do is to put some time in doing this. And then what I'm going to verify is I will verify that you have done it. That's it. So you, in any case, you submit the solution with 60 degrees. I will know that you did it, and I will ask only things of that, of the one of 60. What? It's the same. You do the same.
We can take more profit on this subject, taking more advantage on the solid work and not taking repass on something that we learn.
Yes.
It's like, no, we learn now to make derivatives and
Yes.
something that we learn.
I will explain you why.
Yes, you
Because
explain it, but
because
for me, it's
because
no.
I will tell you why. Because we are going to analyze the results of the motion,
Yes,
and if you don't know that, you will have no idea
but we know
to see.
we pass it to
Yes. That's why I want you to put effort in going into this and refreshing that or learning. And I am asking you to learn 2 exercises. I am not asking you to go through a lot of exercises. No. I am asking you to say this exercise, which you have the guideline, you do it the same with a different angle.
Do you really think if we know to make only 2 exercises, we really refresh it all?
Yes, because no, I am talking about refreshing or learning, depending. Perhaps you don't know.
Yes.
Okay, you will know.
And the people who doesn't didn't this these exercises because the equations you need to plan the
Yes.
equations. So you can copy. If you don't know to do it, you only are copying doing mathematical operations.
Yeah, but believe me, when you change the angle,
Yes.
when you change the angle, you will change. The procedure. The important thing for me is for you to learn one procedure,
Yes,
and to go through it.
Yeah, but different problem is very different.
Yes, but
because the equations are changing.
Yes.
Not
Yes.
at the same time.
Yes,
the same equation.
but you have no time for that.
Just because do it on the
No.
other subject.
Now, in DisMe, you have no time for that. This is for DisMe. And this is something which I will ask you to do later in motion. And you must know exactly where this velocity comes from. That's the reason. Because this, we're going to work on this in motion. And then you will have to go to the analysis of motion and to see values, but you will see no vectors. You will see only values, only graphs of distance, of graph of the solution. And you will have no idea what this velocity means, what this value means, unless you do this. When you do this, then you will know at least where this velocity comes from. That's why I am asking you to do this. Yes.
Si X mayúscula y X minúscula van en el mismo sentido, los dos serían positivos.
Yeah. Sí. Yes. I decided to change them to make it both positive. In my case, I will invite you to solve it, but like this. Not like the one I did, sino the other one with a different angle and with that. Okay, this is what I think is going to be very profitable for you. And I will ask you to submit this one with the different angle, just to know that you did it, and just to verify. Use a verification about that. I am not asking you to go and to study, not this moment, because there is no time. There is nothing for that. For this, then you do have time. Okay? Yeah, and then that's my objective is because when we're going to analyze the motion, we will get back into this to make sense to the graphs. Okay? Okay, what other question? Okay, about this, what else? Or do you feel that everything is, do you feel that you have the sufficient knowledge? Yes, I know that. Yes.
In this part,
Which one? The 5. Okay.
you say that the velocity is this one and this one.
The addition of the two.
These two.
Yes.
Okay. And why do you do this? Why do you decompose the recessionist?
Okay, it was in the other one. Okay, so no, is the first one the second
The
one?
first one.
The first one. Okay,
Yeah.
sorry, I was the second one.
No, this is the second one. Then the first one.
Okay, the first one here, the addition. Okay, so
You have these two, right?
okay,
So I understand that you have these numbers.
yes.
And why don't you add them?
Okay, directly.
Yeah.
Why I didn't do this equation directly?
Why you decompose
In two. Okay, the reason for that is because you must always have the addition or the multiplication or the product with the same axle.
Okay.
All of them must be in the same axle. So this is the lower letter, and this is the capital letter.
Okay.
Esta es minúscula y esta es mayúscula. It means if you go to the drawing, the omega corresponds to K mayúscula. And the W sub 0 corresponds to K lower letter. Okay, in this case it's K, but in my case is different. In my case is here. In my case, omega is K, capital letters, and the Omega sub 0
yeah, small.
is for y, which is the A. A lower letters.
Yeah. So you
E
change,
minúscula.
you change the
This.
the capital letter to the
Yes, I change. I choose one,
yeah.
and I
But
change.
I could change the lower letter.
Oh yeah, absolutely.
The capital letter and add them.
Yes,
with-
you could have chosen the other one.
Okay.
Actually, my advice would okay.
For me to, for
Listen,
me,
listen to this as well. Listen to this. My advice is for you to choose the other one,
okay.
not the one I did.
Yeah.
You use the other one, and then you must compare the final solution, and the final solution must fit. If you compare the magnitude must be the same, and the accelerations must be the same. The final acceleration. Okay, so I advise you to go to the other one. Mhm. And to do the other axle. So, okay, perfect. Perfect. So in this case for you, it's going to be piece of cake.
Why isn't the
Sí, es I.
es J?
Ah, okay, sorry. I put Y here. Yeah, it's J. Yes, sorry. I made a mistake here. I put Y and Y.
Yeah, because the solution is the
The drawing is incorrect. Yeah, the drawing is incorrect. The drawing is J. Yeah, I put the same in both. Sorry. Here as well. It's J.
Y lo tiene resuelto esta mañana. Pasamos a los grandes, a los mayúsculos, y luego a partir de ahí va a estar mirando.
Yeah. Okay, this is also important. What I will ask you to verify, what I will verify that these things is at least to verify that you more or less have the basic things. So perhaps calculate only one of the vectors or asking things about the theory.
Para mí el tema es claro que es eso, dices, bueno, este ejercicio es esta función, porque cada movimiento tiene su producto escalar, ¿no? Dices, bueno, la velocidad de algo B, la de O como la de O como B. Y ahí sacas, pero claro, te cambias el problema, entonces realmente estás sabiendo operar unos numeritos que son un producto escalar y para que te cambies cuatro del mecanismo y no te sirve de nada.
I think you are saying that because you haven't seen motion yet.
Sí.
When we go into motion and we focus and we perhaps you might see what my purpose. Yeah, because the thing that you're saying now, you will have the chance to do it in your project in the segment. If you want to go into a different one, you can choose doing a different one, and then you will have to investigate and we'll have to define. You have to do all the things that you're saying now. But now, in the time we have now for the assignment,
Yeah.
and only what this and that's it. This is what we need to learn the software.
Yeah.
My intention is for you to learn the software, not to go into more sophisticated kinematics.
Yeah.
You will have the chance to do it.
Entiendo que
Yes, you will have the chance to do it. Yeah, yes. But perhaps you're very good in this and you have no problem. But it's not the same. Yeah. Okay. But this is no. I am trying to just explain you why.
Ya, es que si no nos está discutiendo aquí sin fin. Vamos a ver.
Okay. TEOM es teoría de máquinas y mecanismos. Okay. Okay. Any other question about this? But you might have to go through it. I know about that. I know about that. Okay. Yes. Okay. Wait, let's go to the. I call it validation, not exam, because it's not really an exam. You don't have to go to study a lot of things. It's just for me to verify that you have done it.
What is the problem? I don't ask you if you don't approve or the work is validation. What consequence?
You have a lower rate,
Yes, but
and okay, and then I will probably ask you, depending on what, I will probably ask you to do something, and then you will have and you will have a lower rate. So because you must know it, you must know it. So if I see that you don't, then come here, you will have to do this and this extra work. Okay. Okay. Let's go to the calendar. Yes. So what we will have is, yeah, for the design, I will define the values, the angle, and the results for you to go through it. And then in the next class, it's just to verify if everything is okay. It should have been done by the next class. Everybody should. I will ask you to submit it, just for me to have a overall view about when you did it and that it was done. We will verify if any questions, in any doubt. If somebody couldn't finish it, we revise. If everything is okay, then in the time we have, we will go through the article just for you to know. It's depending on the time we have left.
Are you talking about these two different exercises or the different answer document of the variance?
No. The document of the variance is a questionnaire for the next class. That one is for the next class. I will send you an email.
Next classes or Friday?
Yes, on the 29th. The 29th is a questionnaire about the questions. Yeah, but the evaluation on this one will be on the second of the Monday, because for you to, if anybody is still unsure about how to do it, we have the final time for the revision. If you are okay with that and you did everything correct, then it's only waiting until October. Before we begin SolidWorks, we will do this very brief verification. But I will send an email with this information, with the angle, the results of the angle, and this date at this time will be this questionnaire, and this other date at this other time will be this other questionnaire or validation. And that's it, for you to know. Okay? Okay, what time is it now?
Send you like
Okay, let me write the information. Hold on.